this lesson on conic sections, we're going to be covering topics under the standard 2.4 and then also topics under the study island lesson called conic sections. This is going to be part 1 of 2 videos, so if you're working on either of those 2 places, you want to make sure that you watch both videos so that you get all the information you need to be successful. And as always, just remember our study tips, please be taking notes. And it's only going to help you if I go too fast. Just go ahead and press pause and then rewind if you need to and get caught back up. In today's lesson, we're going to be talking mainly about how to tell the difference between the equations of the 4 conic sections, and then we're going to be taking a closer look at parabolas. So I'm so glad that you're here, and let's go ahead and look at some notes.
Conic sections are created by having 2 cones on top of each other meeting at their tips. And then taking a rectangular plane and slicing them. So when you slice them, there's 4 different ones that could be created. You could create a circle by slicing straight across. You could create an ellipse by only slicing one at an angle. Or you could create a parabola by only slicing one at an angle. Or you could create a hyperbola by slicing them both. And in the following questions, we're going to look at each one of these characteristics and what their formulas look like. First, we're going to look at a parabola. And so when you have a parabola, you can have a parabola that opens left or right, or one that opens up and or down. And the way you can look at the equation is if the y variable is what's being squared, it's going to open to the left or the right. If the x variable is what's being squared, it's going to open up or down. And then also in the parabola formula, there's only one variable that's squared. When you look at the circle, the ellipse, and the hyperbola, there is the x and the y are always squared. So in the circle, both the x and the y are squared, but there's no fractions in that equation. Whereas in the ellipse, you both have fractions. However, the ellipse, the fractions are being added, and the hyperbolas are being subtracted. So in the following questions, you're going to be given an equation and asked to identify, is this a parabola, circle, ellipse, or hyperbola? So in this equation, we only have the one squared term, and it's an x. So since we only have one squared term, we know that that's going to be a parabola. A hyperbola, circle, and ellipse will have both the x and the y squared. So then also, since we know that the x is the squared term, we know that that parabola is going to open up or it's going to open down. And we actually know this one opens up because it's positive in front of the x squared. But a parabola that opens up has an axis of symmetry that is vertical. So that's considered a vertical parabola, which is our choice D. So here it wants to know which of the following conic sections is this equation. Well, it has a fraction that's being added. So those are characteristics of a ellipse, which is D. Which of the conic sections is represented by the general equation given below? Well, it's a fraction being subtracted, so I know that's going to be a hyperbola. So a hyperbola has what's called a transverse axis. The transverse axis is the length between the 2 vertexes of our hyperbola. And in order to know which way if it's going to be a transverse axis this way, or if it's going to be a transverse axis this way, is we look to see which variable is first in this equation. I have an x term minus a y term. So because this x is first in the subtraction, that means that my transverse axis is going to go the same way as the x-axis. So it's going to be parallel to the x-axis. If the y was first, it would be parallel to the y-axis. So that means my answer here is going to be B. So here I am given an equation, and I have both variables being squared. However, there's no fraction, so I know that this is going to be a circle, which is letter B. So which of the following statements describes the graph of the equation above? So I have fractions that are being subtracted, so I know right away that that's going to be a hyperbola. And both of those variables are squared, so it definitely can't be a parabola. And here, my x variable is first, so that means that my hyperbola is going to open left and right versus up and down. And because that transverse axis is going horizontal the same way as the x-axis, this is going to be considered a horizontal hyperbola. This equation here, I only have one variable that's being squared, and that's the y. So that means it's going to be a parabola. And here, the variable that's being squared is a y, and this is a positive y squared. So that means it's going to open to the right. The y squared tells us it opens right or left, and the fact that it's positive tells us it opens to the right. And so since this parabola, its axis of symmetry is horizontal, that means it's going to be a horizontal parabola, which is choice B. Okay, this equation here, once again, I just have one variable that's being squared, so that means it's going to be a parabola. So I can get rid of choice B and D. The variable that's being squared is an x. So that means it's either going to open up or down because the variable being squared is x. And the axis of symmetry in these two parabolas is vertical. And so that means it's going the same direction as the y-axis. So that means it's going to be parallel to the y-axis, which is choice A. Now we're going to look a little bit closer at our parabola graph and equation. So the first thing we're going to need to know is to be able to identify which way the parabola opens. Well, if it's the x variable that's being squared, it's either going to be opening up or down. And if that number in front of the parentheses or in front of the x squared term, if it's positive, it's going to open up. If it's negative, it's going to open down. Now we know it opens left or right if it's my y variable that's being squared. And if that number in front of the parentheses is positive or the number in front of the y squared is positive, then it's going to open to the right. If it's negative, then it's going to open to the left. We also need to know how to calculate the vertex. If the equation is in vertex form, then you simply have to take the numbers from the parentheses. So here, if the vertex is in standard form, then we know that x equals negative b over 2a to find the x coordinate. And then we have to substitute that back into the equation to find the y coordinate like we did in our quadratic equations lesson. And then we also use this same formula here to find the axis of symmetry. And we use the x equals negative b over 2a for the up or down, and we use the y equals negative b over 2a for the left and right parabolas. So here they want us to find the vertex of the following parabola. It's in standard form, so we're going to use x equals negative b over 2a. And the opposite of my b coefficient is negative 42 all over 2 times, and my a coefficient here is 3. Remember, a comes from in front of the x squared, and b comes from in front of the x. And so here I have negative 42 over 6, which when I do that division is negative 7. So I know that my x coordinate here is going to be -7, so it's either A or C. So now I'm going to have to substitute that -7 back into the equation for x in order to find my y coordinates. So when I do that, it's going to look like this. And so here I'm going to take -7 squared, which is +49. And then my next step is going to be to do the multiplication. And 3 times 49 is 147. And then 42 times -7 is a -294. And then I have that plus 153. And so when I do that adding and subtracting, I get a final answer of 6. So that means my y coordinate is 6. So that my vertex is -7, +6. And that makes my final answer C. So they want to know which one of these equations is most likely matches to this graph. Well, I have a parabola that opens to the right. So that means that my y variable is going to be the squared one because it opens left or right. And because this is opening to the right, that means the number in front of my y squared is going to be positive. And the only one here that has a y squared with a positive coefficient is D. So that's my final answer. Again, this problem wants us to identify which equation here is most likely matches this graph. Well, this equations here this time, they give them to us in vertex form. The coordinates of my vertex here are -2, -2. So that means that I'm going to have an x plus 2 in the parentheses because it's always opposite sign when it's in the parentheses, and a plus and a -2 at the end because the y coordinate stays the same in vertex form. So the only one here that has that going on is A. So I know that my final answer here is A. All right, this question here says I need to find an equation that has a parabola that opens down and a vertex at 4, -8. So I know it opens down, so that means I know I'm going to have an x squared that has a negative coefficient out front. So that means right away I can get rid of B and C because those have positive x squareds. And so then I just need to look at letter A and D and see which one of those has the vertex for -8. So since they're in standard form, I'm going to start with A and use that formula x equals -b over 2a to find my x coordinate of A's vertex and see if it matches the question. So my B number in A is the number in front of x, which is 8. The opposite of 8 is -8. All over 2 times my A number, the coefficient in front of x squared is -1. And so I have -8 over -2. And so in A, my x coordinate is 4. So that checks out so far. So now we're going to go ahead and substitute in my x number, which is 4 now, into this equation. So I'm going to have -4 squared plus 8 times 4 minus 24. So here I'm going to have -16. 4 squared is 4, with the negative stays up front, plus the 32 minus 24. And when I do -16 plus 32 minus 24, that works out to be y coordinate of -8, which also matches. So that means A is my answer. And you could also work out D then, if it was a test and you wanted to be sure you're right, to make sure that D is wrong and we didn't make a mistake somewhere in A. Okay, in 12, it asks us to find the axis of symmetry of the following parabola. It's the x squared term what's the x term that's being squared, so that means it's going to be x equals -b over 2a. If it was the y variable that was being squared, it would be y equals, but it's not. So then here my b term is 8. So that's going to be opposite 8 is negative 8 all over 2 times. And then I have my a number is a negative 1, the number in front of x squared. And so I have negative 8 over negative 2. And that simplifies down to positive 4. So x equals 4 is my axis of symmetry. Thank you for joining us today, and I hope you learned something new.